Sound is a type of energy that can be heard. When something vibrates or moves back and forth, a sound is produced. Sound waves are created by this movement of vibrations of air molecules. When the vibrations are fast, you hear a high note. When the vibrations are slow, it creates a low note. For example, a small bell creates a high-pitched sound because it vibrates quickly, whereas a drum creates a low-pitched sound because it vibrates slower. The five main characteristics of sound waves are wavelength, amplitude, frequency, which is the number of waves that pass a point in a second, time period, and velocity. Visually, their shapes depend on how loud a sound is or what pitch it is. For example, louder sounds create bigger sound waves, and quieter sounds create smaller sound waves. Higher pitched sounds create a high frequency wave, while lower pitched sounds create waves with lower frequency. These graphs all represent sound waves. They are pictures of the height of the sound wave at a given moment. Something important you need to know about these sound waves is that the wavelength is the distance it takes the function to start over. My question is, how can sound waves be modeled in an equation? I learned that this equation tells us the height of the wave as a function of its distance from the sound source and the time since the sound was made. This A stands for the amplitude, which is the height from the center line to the peak. It's also known as the loudness of the sound. This is 2 pi over a Greek letter known as lambda, which is basically the wavelength. The wavelength is the distance between two identical points of the wave. This x stands for the distance from the source of the sound. 2 pi over capitalized T is the period, which is the time it takes to complete one full cycle. This lowercase t means the time since the sound was made. Here's an example. For this example, 5 is the amplitude. The distance for one full cycle is 4, and the time for one full cycle is 0.5. This is the wave the equation makes on the graph. When I animate this graph, it shows how it's changing over time because, as you can see, the animation is changing t. After I pause the animation, I picked a point. This point means that with a time of 83.8 seconds and a distance of 2.01, the height of the wave is 2.7. And that's how sound waves can be modeled in a cosine equation.